Okay, so this is about forming polymers, and these are all condensation polymers that I'm going to be talking about. So looking at the structure that I've got here, you can see, I hope, that we've got this carboxylic acid group on the end here, okay? And I've written things in different colours because that's going to be helpful later. I can see I've got this C double bond O and then an OH sticking off the bottom. And this one here is an alcohol. We know this because it's got an OH group sticking off it. Now the thing that's different here compared to the esters that we were looking at before is that the molecules are kind of mirror image of itself. So it's got a carboxylic acid group on the other end of itself as well. And this alcohol has got an alcohol group on the other end of itself too. So where these can react and make an ester group, they can also do it at the other end of the molecule. So we'll be able to join lots and lots of molecules together in sequence. Now just to remind you again, it's called a condensation reaction because the byproduct of the reaction is a small molecule. Now in this case it's water, and you can see because it's taking the H from here and the OH from the alcohol, and the two of them are going off together and making water. Now what's left behind is just the blue sections of the molecule, and that's what you can see where I've drawn underneath here. So you can see the remains of this carboxylic acid group here, and then all that's left of the alcohol is this little squiggly bit in the middle, which will be some length of alkane chain. We don't need to worry about how many are in it. And there's that little squiggly bit there, and that links onto the next carboxylic acid group on the next molecule. Again, a little squiggly bit in the middle for an alkane chain separating those two carboxylic acid groups. But you can see we've got lots and lots of ester groups all replicating all the way along the length of this molecule. And because of that, because there are many ester groups, we'll call it a polyester. Okay? So exactly the same as the esterification, the ester reactions that we looked at before. It's just the difference this time is that it's happening at both ends of the molecule, so we can join lots and lots of molecules together. As I'm sure you all have heard of polyesters. I'm about to show you how to make one. This one's slightly different because this one's actually going to be a polyamide, and all that means is that instead of this oxygen here in the chain, we have a nitrogen there instead. Okay, same here. Instead of this oxygen, we have a nitrogen there instead. But it's a very similar reaction, and the two molecules join together, one then the other, then one then the other, and it still produces a tiny molecule as a byproduct. So it's still what we call a condensation reaction. Now, this is the reaction here. I've got these two chemicals. This is the chemical that's got the nitrogen in it. I'm just going to pour a little bit in there. Okay. And then this is the chemical that's got the carboxylic acid group. Now the two chemicals don't mix very well, so they're going to go in two separate layers, and it will form a kind of a skin in between where the two layers are touching. So you might see a little bit of misty fumes as I pour this one in because it's quite a vigorous reaction that happens. Yeah, there we go. So pour that one in nice and carefully. Okay, now the idea is that where these two molecules meet, they'll be doing one of these sorts of condensation reactions. But at the moment, because they're in two separate layers, one above the other, the only place where they can meet is on that membrane, on the join. Can you see me okay?
No.
Okay, right, so the only place where those two molecules can meet is on that join. So we've got the top layer and then the bottom layer, and where they join together, where my finger and my thumb are touching, where those two layers join together is where those two chemicals can touch and react, and that's going to be where they're starting to form the polymer. So if I use these tweezers, I can literally reach in and pluck at the membrane between those two layers, and you'll see it come up as a polymer. Okay, and I can wrap it around here. It looks like a disgusting bit of dental floss. Okay. So I can keep pulling and twiddling that, and it will keep carrying on making that polymer until both those chemicals in that beaker have run out. Now, I don't know if you can zoom in a little bit on this to see how that membrane's plucking up from the middle, and you can see where it pulls away from the edges. That allows more and more chemical to touch and react. See? Okay, and that's just going to go on and on forever. So the chemical I'm making here, the polymer that I'm making, is actually nylon, the same stuff that you make tights out of. So it would need to be rinsed and washed, because at the moment it's got lots of surplus chemical all over it. But once that's been rinsed, it can then be melted down, spun into little tiny threads, and then knitted up into tights and stockings and so on that we can then use. Or it can be made into little solid shapes that they use for making often things like gears and machinery. Okay, you see it's going quite well. It's quite disgusting actually. All right, I'm going to stop it now. All right, you can stop.